All right, hello everybody. Welcome to the first part of the video for section 3.3. And you haven't been making many comments on these videos about the memes I post, but I think this one's a pretty good one. I'm kind of proud of this one. All right. Anyways, we are starting section 3.3, and we're going to do a deeper dive into polynomials now. So we had an intro to polynomials in section 3.1. We looked at a specific type of polynomial, quadratics, in section 3.2, and now we're going to generalize even more about polynomials in section 3.3. Now, we're going to continue our discussion about finding horizontal intercepts, which we know, first of all, that in general, when we need to find a horizontal intercept of any function, we just take the function and set it equal to 0, and then solve for the values of the input variables. And when we're doing this for polynomials, there are three primary methods we want to utilize. So the first is trying to factor the polynomial using any method we know, greatest common factor, trinomial factoring, which is what we did with quadratics, any of those if we can. The second one, and perhaps the easiest, is if the polynomial is already given in factored form, then finding the horizontal intercepts can be quite straightforward. And the third one, if the other ones fail, is to use technology. And by technology in this class, we primarily mean our graphing calculators. Okay, so let's look at these. So first, using factoring to find horizontal intercepts. Well, first of all, we're told to find the horizontal intercepts of this function, g of x equals x to the fourth minus 16x squared. First thing we need to do here, just like I said before, since we're trying to find horizontal intercepts, is set the equation equal to 0. So 0 equals x to the fourth minus 16x squared. And then from there, we'll try to factor. Notice that we have an x to the fourth and an x squared in our terms here. And so because of that, because they both contain at least x squared, we can actually factor an x squared out. And when we do that with the first term here, we're left with just x squared. And with the second term, we're left with minus 16. And you can double check that if you distribute this x squared back in here, you will get the thing that we started with up here. Okay. Sure. Now, before we continue solving this, it also turns out we can do a little special factoring trick with this right here, this x squared minus 16. Because that is what we call a difference of two squares. Okay, so here's what I mean by that. If we have something in the form a squared minus b squared, meaning something squared minus something else squared, that can be factored to be a plus b times a minus b. And again, this will work for this x squared minus 16 because if we notice, this is the same as x squared, so something squared, minus 16 is the same as 4 squared, right? And so because of that, we see that it follows this a squared minus b squared format. And so because of that, we can factor that x squared minus 16 further. So it becomes x plus 4 times x minus 4. And then from there, we know from our study of the zero product property that to find the values for x there, we need to take each piece and set it equal to 0. So we'll have x squared equals 0, x plus 4 equals 0, and x minus 4 equals 0. We can solve each of those. And for the first one, we could take a square root on both sides. Take a square root, we get a plus or minus answer. So we'd have x equals plus or minus square root of 0. But the square root of 0 is just 0, and plus or minus will just make 0 again. X plus 4, if we solve that, we'll get x equals negative 4. And x minus 4 gives us x equals positive 4. So from those, again, we'll write these as coordinate points. We see that our horizontal intercepts for this function would be 0, 0, negative 4, 0, and 4, 0. Okay, so those would be our 3 horizontal intercepts on that one. So that's an example of using factoring. Now the second technique we have for finding horizontal intercepts, again, is the one where the function is already given in factored form. Okay, so which is what we see here. So everything's already been factored out. And again, we'll start by setting the equation equal to 0. Okay, and then again, using the zero product property, because we see a bunch of things being multiplied here, and they're all multiplied together to equal 0, we can solve this by taking each piece and setting it equal to 0. So we can do t minus 1 squared equals 0, t plus 2 equals 0, t minus 3 equals 0, and note we don't need to set the 1/3 equal to 0 because 1/3 will never equal 0. From the second two, we can see, hopefully fairly straightforward, that we get t equals negative 2 and t equals 3 there. For the first one, before we can add 1 to both sides, we've got to get rid of the squared, so we do that by taking a square root on both sides, and again, when we take a square root, we get a plus or minus. So t minus 1 equals plus or minus square root of 0 was, we just saw a second ago, square root of 0 is 0, plus or minus that, well, that's the same thing. So we get t minus 1 equals 0, which just gives us t equals 1. And so for this function, we see that our horizontal intercepts occur at the points 1, 0, negative 2, 0, and then 3, 0. Okay, and those will be our horizontal intercepts. All right, well, let's look at the final method then. When all else fails, using technology. Now, as we go through this example, you'll see that this is one that works for any polynomial, actually. So regardless of whether it's given in factored form or can factor or not. But I will say this is one that it's always helpful to try to use the other ones before trying to use this one, because using technology sometimes is not any faster than just doing a problem out by hand. All right, so we have this polynomial, h of x equals 42x cubed plus 83x squared minus 22x minus 15. We need to find the horizontal intercepts here. Now, first of all, note that we could try to factor this one, but like if we look between these two here, we'd have like an x squared we could factor, and then I don't know what's the same between 42 and 83. I don't think they have anything the same, so we'd end up with 42x plus 83, and then between minus 22x and minus 15, well, the only thing they have in common is a minus sign. That would give us 22x plus 15. And notice this isn't looking very promising for factoring. So this is what tells us we need to use technology here. And so here's how we would do that. So we'll go to our graphing calculators, or whatever you are using as your graphing calculator in this class. We'll hit this y equals, and then we'll go ahead and input the function. So 42x cubed plus 83x squared minus 22x minus 15. And we can graph it. And notice we can kind of see the horizontal intercepts here, right? So they're occurring at this point, this one, and this one, although the window scale is not really good for what we're looking at, so we probably maybe want to change our window scale, especially because there's a bunch of empty space out here. And so based on what I see here, I'm going to go into my window. I'm going to change my x values to go from, say, -4 up to 2. Let's graph it like that. Okay, and now it's much easier to see where the horizontal intercepts happen. Again, they're right here, and right here. We can kind of guess what they are. Like the first one looks like maybe it's at like negative 2.1. Next one looks like maybe like negative 0.3, but it's hard to tell. So we can use some features of our calculator then to help us figure this out. So the way we do that is press second trace. You notice there's a button up here that says calc. And then it'll give us these options. And because we're looking for horizontal intercepts, so recall that another word for horizontal intercepts is zeros. We can press number 2. And then what the calculator is going to ask us for is a left bound and a right bound. And basically, if we're trying to find this horizontal intercept here, we need to give the calculator 2 values that we think it's between. So we said this one was negative 2.1. So to find a left bound, we need to scroll using the arrows here until we get a value that's less than negative 2.1. So wait for my little clicker to come up here. And you can see the clicker coming, the little marker there. So negative 2.18, that's less than 2.1. So I'll put that in, press enter. And then I need a right bound, which means I need a number bigger than negative 2.1. So I could go to like negative 2.13 or negative 2.09. That's bigger than negative 2.1. Press enter. It'll ask for a guess. We don't need to put a guess. We can just press enter. And then it gives us that intercept right there happens at the value negative 2.143, 0. And then we can repeat that process for the other one. So we can go to this one here. Again, we thought it was negative 0.3, so we'll hit second calc. Again, go to 0. And I want to go to a number that's less than negative 0.3, but I also want to go to one that's close to it. So like I wouldn't have done negative 2.09 or negative 1.7 or something like that. I need to make sure I'm close to the value I'm trying to look for here. Sometimes it takes a while to get the clicker here to show up. Okay, there it is. So we're at negative 0.36. That's less than negative 0.3. So press enter. And then go a little bit bigger. Maybe right there, negative 0.27. That's bigger than negative 0.3. Press enter again. And here we find that our 0 is at negative 0.333 repeating, which you might recognize as that being negative 1/3, 0. Okay. And you could repeat that process again for the last one. Cool. Thank you guys for watching. That's it for now.